Welcome to the future. Technologies and innovations that sculpt our industry. This episode recorded live at the 2024 AHR Expo. To learn more about each of these topics, join us at the National HVACR Education Conference in Las Vegas at the end of March. All right, everyone, thank you so much for joining us at the 2024 AHR Expo. We're spending a lot of time talking about these new technologies. We've all had an opportunity to explore the floors, see things that are happening in the industry. And I think one thing we can all agree on is that we are all moving into heat pump technologies, right? A lot of cold climate heat pumps. We're seeing a lot of heat pump water heaters. I'm even seeing R290 air to water source monoblock heat pumps out here on the floor. I've been talking about these for a long time. People go, yeah, you're crazy. We're never going to get those here in the US. But we're all going to see challenges adopting and adapting to cold climate heat pumps and just heat pumps in general, inverter heat pumps specifically. So my name's Clifton Beck. I'm the host of Did You Know, the ESCO HVAC show. And we have three completely different perspectives from our industry that I am just so anxious to share with you. So let's introduce each other. David, you'd like to start off?
Yeah, so my name's David Rames. I'm the Senior Product Manager for MIDEA. So we're in charge of innovation, right? What's coming, not what's in the past, not what's now, but what's coming. So we got to keep our finger on the pulse of where we're going. And Clifton's right, cold climate heat pump technology is the future, so that's what we've got to work on.
Okay. Christopher?
Yeah, I'm Christopher Dymond. I'm a Senior Product Manager at the Northwest Energy Efficiency Alliance, and my job is sort of a blend of emerging tech. What is the next thing that has incremental energy savings and product differentiation, and to understand what are the barriers to whatever that technology is, and what can a organization like NEEA do to remove these barriers.
Yeah, absolutely.
Yep, and my name's Alex Rees. I am the Residential HVAC and Water Heating Lead in the Building Technologies Office at the Department of Energy. So obviously we have a very broad scope working on a lot of things, but a lot of our mission is to try and fully decarbonize the U.S. building stock by 2050, which obviously involves cold climate heat pumps and mass deployment of them.
Yeah,
so
that's
a lot of work to do.
That's a lot of effort there, right? And so we're all here together to talk about these difficult situations. So when we look at the adoption of cold climate heat pumps and inverter heat pump technology, why do you feel that the industry is struggling so much? I mean, I see it myself from the technical perspective. So for me, I work with a lot of technicians that grew up working on one particular piece of equipment. You know, I use this analogy in a couple of my other podcasts that when I was a young man, I worked on my vehicle, and my vehicle had a carburetor, and it had mechanical ignition system, and I can adjust the timing using a timing light and mechanically adjusting the distributor. But it was all used in the management of an internal combustion engine. And I happened to be in that time period where we were moving into throttle body fuel injection and multi-port fuel injection. And so I was getting the chance to work on both of them. My old technology that operated on carburetors and my new technology that operated on throttle position sensors, exhaust gas recirculating temperatures. We looked at intake temperatures. We had a variety of inputs that manage our output. And the interesting thing about it was I didn't have to relearn the internal combustion engine. I relearned the new, more advanced ways to control that engine. So when we look at our emergence of inverter technology, I feel the same way. I feel like I grew up working on things that had capacitors and PSC motors and piston metering devices and maybe expansion valves. And then all of a sudden I introduced an entirely new logic where I'm using pressure transducers and temperature thermistors, and I'm using algorithms to manage my outputs on an internal compression engine that didn't really change a whole lot in its design, just in its control. So as a technician, I may not have been comfortable moving into this technology, and it's a shame because I should have. I've seen that transition in automotive, and now I get to look at it into the realm of inverter technology. So why do we see, let's think about some other perspectives of why we're having struggles adopting these new technologies. Maybe let's just start from the manufacturing side. What do you hear from contractors and from the manufacturing side of our industry?
Yeah, well, education is key, right?
I think that. I think that really is our
topic. Education has to start from the manufacturing level.
Sure.
And so we understand the technology because we innovated that technology.
Right.
So
you understand it.
We understand it. And so everyone still says, And my grandpa had a heat pump, and it was 40 degrees outside. We all froze to death.
Yeah.
And no one knows that technology has changed.
It's so much different.
And I've got a quick stat in front of me.
Yeah,
And
yeah.
So,
Oh, we love numbers.
Our PR company did a consumer research, and they basically said the question was, how many know what a heat pump is? 80% of people said, I know what a heat pump is. And then they said, how many of you know that there are heat pumps on the market that can give you 100% heating output at negative 4 degrees Fahrenheit? And that stat went from 80% to 4%.
4.
They
That's
don't
pretty
know.
drastic.
They
They don't
don't
understand the capability of them.
No, they don't know what it can do.
Yeah.
So it's up to us to teach them what it can do.
Wow, that's a very significant stat, because then we look at, well, now we're talking about the consumer side of things, right? It's not just that our technicians are struggling to move forward and they have some gaps that need to be filled. Even our homeowners don't know what can happen. But it also goes back into the contractor
course.
not being educated enough to be able to inform what we're really doing for that consumer.
Why-
Man, that's a perspective.
Why would a contractor want to take the risk of installing a technology and not having enough backup? And so when they're faced with this challenge of, do I size for the coldest day of the year? That adds a whole nother complexity to their decision-making processes and their risk.
Yeah.
It's far easier just to size for the cooling and have it switch over to
Like we've always
strip
done in
heat
the
or gas,
past,
and,
and-
then it's just a fancy air conditioner that does some backwards working for a while.
That's
With
such
an
a great
oversized
point.
gas furnace as well.
Yeah, in many applications.
That's what they do.
Yeah, so we definitely see from the manufacturing side, we're gathering data, we're understanding that our consumers have changed a lot. We also have to understand that we may need to rethink our decisions in sizing and selecting equipment in a new perspective. Let's talk about that a little bit, Christopher, because I'm sure that's a gap that you do a lot of
That is what
analysis on.
I've been looking for the Goldilocks zone, and that's
Right.
We had a project at NEEA that I called Project Baby Bear, because we were
Oh.
looking literally for what is that blend of variable speed, but not too expensive.
Yeah.
And where I live in the Pacific Northwest, it's a pretty mild climate, so I don't need
Okay.
super capacity at 5. I need good capacity at 17.
Oh,
Much
yeah,
easier.
yeah.
But then
Sure.
I want to challenge you to say, what happens if I've got a dual fuel situation? Do I need a cold climate? It depends entirely on what you mean by cold climate.
Oh, yeah. There's
You can be on the NEEP database, which
Yeah.
lists all the cold climate spec machines
indeed
out
my
there,
favorite resource.
and some that are not got any capacity, particularly at cold. And so, if you're designing a system and you know you're going to have backup fuel, when that heat pump is running during the mild hours, it's ramping slowly up, slowly up. As soon as it hits full power, what happens? It can't keep the house temperature up, so it switches over to gas.
Yes.
So at that moment, you're no longer running the heat pump at max capacity. So the whole Goldilocks kind of project revealed, if you're doing dual fuel or if you're in a mild climate like I'm after, the sweet spot, the Goldilocks zone, is actually a heat pump that's super efficient at part load.
Right.
So that's a really different.
That's a different
thought process.
dynamic than what we've been educated
We're
on
not
and
just saying
gotten
size
comfortable
for the
with.
maximum. It's performance is at the minimum.
Right. Yeah.
What does that mean?
Performance. Well, isn't performance comfort?
I'm a performance guy. I want to get the kilowatt hours minimized, and comfort maximized.
Right.
And knowing 99% of
game.
the time it's going to be running on, not full capacity.
Yeah,
it's going to
exactly.
be somewhere in the middle.
Right. Yeah. And how does it perform?
But if you're going to design to meet the 100% of the load, to do the full decarb that US DOE is doing, you got to have some pretty good equipment.
Yeah.
Definitely.
Yeah.
And luckily, in speaking of pretty good equipment,
Yes.
we have the cold climate heat pump challenge that DOE has been running for the last few years, trying to create these technologies that can get down to negative 15 to 5, depending on which section of the challenge you're using, and run at full capacity with really high COPs, with the
Yeah.
goal of allowing the possibility for full decarbonization. And depending on where you are, you may or not be there right now, but in the future, obviously, that's the goal.
Yeah, absolutely. I've seen a lot of equipment out here from our manufacturers that are seeking that challenge, and it's interesting what I have recognized in that. It's kind of like when we had fuel crisis that kind of drove the efficiency of the automotive industry. It created all products to start re-looking at efficiency. So here I'm finding a lot of inverters that fit that bill in that medium performance range, going, oh, you know what? I can make because I have now grasped the ability to improve my technology in this coldest of applications, we've actually found ways to make our middle products more efficient and actually reduce some of the cost in those. So one of the things that I see, which is really, really interesting, is a shift in the types of equipment that we're manufacturing. Because I think I would assume in that research we're seeing, Christopher, that inverter drives the performance in all pieces of equipment. And so it challenges the
Inverter
equipment.
and controls, but just because it's got great capacity when it's cold doesn't mean it knows how to modulate well and extract the most out of the mild hours.
Right.
This is really not the fault really of anything more than we've set a target saying seasonal heating performance factor, HSPF.
Yeah,
And
an
so the
average.
designers are thinking about how do I hit my price point, my target, all
Absolutely.
that, and I've got to get that HSPF. And then I'm raising my hand saying, "Hey, wait about the mild hours," and
Right.
they're not focusing on that. But I think over the next couple of years, we'll see. I think kind of an interesting dynamic around if you're going cold, go all the way.
Yeah.
If you're going mild, let's think about the right solution for that and defining that in a way that people can really, because those mild climate heat pumps
Yeah.
are not going to cost as much. They're not going to have as big
Initial,
evaporators
yeah.
and condensers. The compressors aren't as big. They'll still be variable drive because you really, that's the key, is it has to be a variable drive to extract that part load efficiency.
Exactly. And I think what manufacturers are doing, especially in MIDEA, is our products, we try to price our products where we can get into as many homes as
Yeah,
possible. right?
absolutely.
We don't-
That's the
we don't
goal.
wanna
We all
have
move
this-
boxes.
Exactly.
Yeah.
We don't want to have this product that only the upper 1% can afford.
Yes.
So let's try to get into as many, and that's where we make a difference, right? That's where we can find that sweet spot, or that's where in a super cold climate in Canada or Alaska we can take care of business. But we got to make it affordable for a lot of different consumers with a lot of different budgets.
Indeed. There was a time where I looked at inverter, the ability to market and sell inverters as a very short percentage of my total product line. And it's becoming obvious that that role is really flipped in the industry, where a majority of my product line is now going to be inverter-driven equipment. I've seen some amazing mid-tier efficiency inverters out here that many of our manufacturers are saying, that's what we would have called baseline a while back. Now this is the standard. So we're looking at these, 15 to 17 SEER pieces of equipment going, well, now we have this as an entry line almost product, and we can put that in that mid-tier place and take over a lot of the strain on price, the strain on education. But it really comes back down to our professionals really have to be educated on what these differences are. So let's take a look at that and think about ways that we can motivate, from different perspectives of the industry, ways that we can motivate our contractors to
All right,
learn
Clifton,
this.
before you go there, I
Yeah.
got to correct you on something.
Yeah.
You're using the term SEER.
Oh, I know. I got to break that.
I gotta
That's old
break-
habit. See, it's how can
So
we modify
this is the
educators
key, is
to
that
learn?
We're talking heat pump now.
We gotta
We're
get
talking
into
about, We got to
HSPF.
talk about the heating season performance factor.
That
and
is so
not
true.
just cooling.
Yes.
We've been talking about heat pumps, and when you say SEER,
Yeah.
people think of it's an air conditioner.
I know. That's why we're here to break bad habits. I was a technician that grew up in this carburetor area, this PSC compressor, piston driven, maybe have an expansion valve driven systems, and went, all right, these are decent pieces of equipment, and this is how we do this. This is how we've always done this, right? Isn't this how we're supposed to do it the way we've always done it? And no, we're not.
I'm going to catch you on it again.
I'm glad you do, because I'm just as much at fault as everyone. We've always looked at things from the perspective that we had and thought that that was the way to do it. But now we're actually getting challenged to look at things from a new perspective. And that's really the fundamental change that has to happen for contractors, I think.
And while we're breaking bad habits, we can start calling it HSPF2 and SEER2 as well.
Exactly. See?
Touche,
Oh, look at that one. And so, exactly. So we have to understand what these differences are and look for those resources. So let's think about ways that we can promote contractors to look for these resources from different avenues within the industry.
So I think what we've been successful at so far, because again, we take the pressure of this education as a manufacturer.
Yes.
So as my technical training and product training group travels North America, to train our manufacturer, our distribution partners, we've asked, bring your contractors in.
Yeah.
Because we can train you and we do a good job and you do a good job. But if we've got an auditorium full of your contractors, they're going to
Yeah.
hear it right from the horse's mouth.
Exactly.
The guys who designed this. And then they have the confidence and they go, boy, oh boy, now I kind of see.
Exactly. That
And
makes a change.
And what's the perfect scenario for us is on the contractor side, they always go out, hey, Mrs. Jones, here's a good, better, best application. How do we get good, better, and best to all be inverter driven? That's the goal.
That is a great
Right,
challenge to
but
look
whose
at.
definition is it good, better, best?
Oh yeah, yeah.
Some ideas? No. The reality is that clear data is really the underlying thing is that having availability and access to data.
Yes.
So that's what the NEEP database is.
Tell me more about this because I just was introduced to it by you, and I am just like ecstatic about
right.
this NEEP database.
So NEEP is the kind of the equivalent of NEEA, but they're in the Northeast.
Right.
So it's a Northeast Energy Efficiency Partnerships. They started up a cold climate heat pump database.
Yes.
And it's really caught on because anything on that list has a COP of at least 1.75 at 5 degrees.
Mm-hmm.
So it has at least some reasonable capability at 5 degrees.
Right.
Maybe not full capacity, but it's on there. But the cool thing about this database is it's got all kinds of other operational condition data that is reported, self-reported by the manufacturers, and includes it in a format that people can look at and compare and evaluate. Utilities are using this, forecasters are using this, we're thinking about using this. There's a really neat kind of tool within there to help you evaluate the right size and application for that. It's their advanced, I guess it's a heating selection
I would say so.
option.
Yeah.
Take a look at that. Just Google NEEP heat pump database or cold climate database. It's there.
Yeah.
And we've been using this database quite a bit for some of our projects as well. It is a great resource. In fact, right now we're in the process of creating something that we call the Cold Climate Heat Pump Selection Tool. It's not quite released, but it will be over the summer likely, with the goal of walking a contractor through how do you choose a system based on the characteristics of the house. And in the end, we're creating an API right now to connect it to the NEEP database with the goal of kind of saying, here are some actual options from the NEEP database that are going to meet these criteria. We recommend choosing one of these heat pumps.
Excellent. When we talk about education, I feel that we have a huge opportunity within our industry, whether we're a contractor, whether we're a distributor, manufacturers even. We have generations that are growing up. I'm starting to feel a little bit older because now I'm seeing like 3 generations below me, and I'm going, okay, I've got a lot to talk about. When we start talking about the generations below, like we think about Generation Z and Generation Alpha, we talk about generations that have grown up with technology. Do you see that as a very good tool for introducing inverter technology and controls into a contractor's environment? Because I particularly do. I almost feel like we need a third role in a contracting business. We typically have you either going to go to installation or you're going to go to service. But now we have a generation of very technologically savvy individuals that want to embrace this technology that could really be key in doing proper commissioning and understanding how these systems are developing. So I'd love some input from other parts of the industry on that.
I just came about 2 hours ago from a panel where we spoke in front of about 100 kids from the Chicago school system who are going to go into the
nice.
trades.
Yeah.
And that's exactly what I said is the old fogies are leaving, right?
We're retiring out. We're teaching, and we got to learn.
This younger generation because now these are basically computers.
Yeah, they sure are.
The
Yeah.
technology, and you guys are into this stuff.
Yes.
Get in. You're more technologically savvy than the old fogies. Get into this. Improve the industry. Make some money. Create your value, and then you'll have a career for the rest of your life. You'll never have to look for another job.
You also kind of hit on something, which is the expectations of this younger generation is to communicate with whatever they're working.
Absolutely.
Through their phone, through that kind of digital
It's got to
medium.
connect in some way.
So when we say beer can cold,
Right.
that doesn't really mean anything.
Right.
When you say, I need you to do a 3-dimensional interpolation of a database while you're in the field and your knees are in the mud, that's not going to happen either.
Sure.
But if you could look up at it on your phone and have it kind of guide you through it.
Yeah, connect in. Have an idea how this thing is
That
actually running.
I think is sort of. I have been meeting with a lot of OEMs, asking them about where they are on this sort of pathway. And,
Yes.
And there are some that are further along than others. But they're all aware of this is an important next step.
Right.
Yeah. And speaking from the younger generation, I'm only 24 years old, so
Yes.
solidly in the
Absolutely.
Gen Z area.
Yes.
I remember in school doing interpolations on PV diagrams and to calculate different refrigerant charges, and I mean, I hated it.
Right.
It was miserable. And so I mean, DOE and I think the industry at large is like Christopher was mentioning, transitioning more towards online tools, and we're really trying to promote that, trying to get more Bluetooth enabled tools that allow you to use a smartphone, does all the calculations for you. It improves the commissioning, improves all of the contractor values that they're putting into the system, and it makes a better overall experience both for the contractor and for the resident.
I believe
If it's not installed correctly and it's not commissioned
never gonna
correctly,
perform.
they're really not buying what was
No.
sold to them, right? From an efficiency
that's exactly right. Yeah, I
Yeah,
agree.
so just set the crossover at 45 degrees to the backup heat and don't worry about it. Right? No,
Those
no,
are
no,
the
no, no.
things that
Don't
we've
do that.
been-
Don't do that.
No,
Don't
that's
do
what
that.
we've been taught, though. But those are the things that we have seen in the past because of misperceptions of performance and comfort, and so we have a lot to teach on how things can operate. I think back about some of my friends when we went into electronically controlled engines. It didn't take very long before we had young technicians that became tuners of vehicles, that actually took their knowledge and looked at a system, looked at a vehicle and went, you know what, I can actually tune this thing to be able to perform in the way that works best for my area, and my climate, my altitude. And so I see that as such a opportunity within our industry to be able to take these students, get them in the hands of the technology, absolutely teach the fundamentals of what we're working on, but use that technology to look at a piece of equipment and go, you know what, maybe I need to adjust airflow in this range, and because I'm now using inverter technology and I'm using variable speed motors, I might look at a bandwidth and go, you know what, I need more capacity in this spectrum, and I can actually fine-tune my airflow, which is going to compensate on my capacity in a particular range. And we've never talked about that in the past, and I think we should now going forward, knowing that we have these capabilities within the equipment that's out there.
Yeah.
I mean, these kids were fired up that I spoke to.
I bet they were.
And I think they came in with the misperception that it's just dirty work. But when I talk, my son went into the trades and he's making great money.
Yeah.
And he's got all this money, and he says, and Dad, I can fix my own stuff.
Isn't that a
too.
great feeling?
I
Yeah.
can save money by fixing my own stuff and
Sure.
make money by doing this.
Yeah, it's a
And
great
so they
feeling.
were pretty excited about it. So I think the future looks pretty good.
Well, let's talk about some of this technology right now, because we have a lot going on in that area. We have a lot of research happening. I know from the Department of Energy, we've got the smart diagnostic tool promos that are going on where we're highly encouraging using smart diagnostic tools. Let's look at data for a little bit. And what are we doing in the OEM side when we're looking at service tools? I'm starting to see a lot of equipment that has more diagnostic capabilities in it than we've ever encountered before.
Right. And so within our heat pump, we've got what's called a Dr. Smart tool.
Oh.
This Dr. Smart tool plugs into the heat pump itself, and you can see everything it's doing, how it's working, and you can fine tune. If you need to test, you from outside can ramp the compressor all the way up, ramp the compressor all the way down, and see exactly what's going on. So we talk electronics and diagnostics. This Dr. Smart tool helps us and helps our contractors who are installing it really dial it into where it needs to be.
Yeah, I really like that idea. I know we start seeing changes in other industries that goes along with diagnostics. We've talked about changes that we're seeing in heat pump water heaters, in general, just water heaters have connectability to it. I hope that we see that going forward. And Alexander, can you inform us a little bit more about the DOE initiative on smart diagnostic tools, where we kind of stand in that scenario?
Happy to, yeah. So we have a campaign right now called the STEP campaign, which stands for, smart. Getting stuck already.
Smart test instrument.
Smart testing. There's an energy efficient HVAC in there somewhere.
Yeah.
Pretty much, the idea of using Bluetooth enabled tools that
Yes.
connect to your smartphone to allow for more exact calculations of the various temperatures, pressures, charges that you're trying to calculate. Excuse me. And so the goal here is both to work with the contractors to get these tools into their hands, get them trained on the tools so they know how to use them appropriately.
Yeah.
And also try and demonstrate to them why this is actually better for their business model. If you're using
like
these
that.
tools and the equipment you're installing works better, you get fewer callbacks, you're wasting less money going back to these sites. You're getting better reviews from your customers
Sure,
because your
absolutely.
technology is working great. They're not having any refrigerant leakage down the line and not seeing the performance that they were promised or expecting. And it's going to improve your business. It's going to make your job easier. And there's a little bit of an upfront cost in getting the tools. And we're trying to work on how can we lower that cost? How can we get these into contractors' hands through a variety of different methods? But all about getting those tools into people's hands and recognizing them for doing it.
Yeah, and the ability of them. Yeah. Okay. Do you have something?
Yeah, I wanted to share a little bit of
Yeah.
the utility perspective of
Yeah,
what
that's
heat
really
pumps are
important.
going on, right? So here's the core reality is that we're moving heating more and more into electric-based heating with heat pumps.
Right.
So in a sense, in the next decade or two, that with heat pump water heaters, with heat pump space conditioning, and with electric vehicles, we're going to be pushing twice as many electrons through the same size wires, and that's freaking the utilities out.
Yeah, I can see
Because
that.
if you think about adding another distribution line or another feeder, these things can take 10, 15 years to permit, install, get up and running. We don't have that kind of time.
Right, that makes sense.
So the
Sure.
data that the utilities are now asking for is we need some help being able to inform the heat pumps when we are in crisis mode and when
Yeah.
we would appreciate a demand response, as we used to call it. But it's really more about load flexibility. It used to be we think about demand response is only occurring in the peak hottest day of the year
Yeah.
or the
Yeah.
whole coldest. And I'm here to tell you guys, the highest prices are no longer occurring necessarily at those moments. It's happening
That's interesting.
fall, in the spring. In the Northwest, we have dry rivers in the fall. It's mild times.
Sure.
And all of a sudden, the wind stops blowing, and
We're
bam,
not
the
producing
prices
as
go
much
shoot.
supplementary
So
energy.
we're now looking for how do we work with the heat pumps, water heating. That's going to be the first lead out. That's really going to do that because a water heater is kind of like a giant battery.
Yeah, absolutely. We got
But
storage
the
capacity.
amount of storage in a house in terms of the shell and all that is comparable. No, it's on the same order of magnitude, roughly half the size of a giant tank of water. And so there's a lot of opportunity for the electric utilities to start sending price signals into the market saying, if you got a piece of equipment that works with us, we can compensate the customer. And you better be bringing products that have the ability to work with us to the market, or you're going to miss out.
Yeah, I can see that.
So getting
very
that
much.
whole like when
that
you go out-
momentum. Yeah.
if you're out in the future, you say, I want to buy a heat pump that's smart enough to help me select when to buy heat, when to buy electricity.
Absolutely.
That is a big deal in the next 5 years.
Incentives drive
Yeah.
consumer behavior.
Absolutely, it does.
And offsets. If this equipment is more expensive, that rebates and things like that can help them make that buying decision. But then long term, that payback comes back quickly.
So the interesting
Yeah.
about incentives is we were basing mostly incentives on energy saved to avoid a new power plant.
Uh-huh.
Now we're really more worried about energy saved to avoid that peak price during the day. So it's shifting the dynamic of when we need efficiency. We need efficiency and flexibility at the same time. And
Inverter
that's
gives
something,
us that.
honestly, we haven't figured out on the utility side. We're still figuring that out.
Sure. It's new for everyone to think about
Yeah.
it. But it gives us the capability. When we move into inverter technology, we can now do that. If we think about our traditional single stage or two stage pieces of equipment, the only thing we could do to reduce our capacity at a peak demand was turn it off.
Turn it off.
And we actually did that for many sectors of the country. We experimented with that. Could we do that to manage energy at peak demand time? And so that was successful in many markets. If we think now about, well, why don't we just reduce the capacity of that for a little while? Let's just change the capacity within the structure for a little bit and compensate for that so that we can now modulate our electrical and balance out our load a lot. I absolutely love the idea of that. And it brought up a really interesting perspective, kind of came from this last answer that you had, David, is, well, what about our consumers? So when we think about consumers, they're a lot of the driving force. I mean, as a manufacturer, you're going to produce products that is in demand and is being expected due to regulations, right? We all have to comply with what regulations are and expectations. But without the consumer buy-in, we may never have the demand, because some of our contractors are coming back to us going, well, my consumer is not really asking for this, therefore I don't have to sell this. I'm going to keep doing the same thing that I'm doing. But I don't think that's very realistic in our industry. So do we see many consumer campaigns coming up in the future to help educate consumers and contractors on the newer advanced technologies?
Yeah, well, there needs to be. Again,
Yeah.
I think the education responsibility is on the manufacturers, and we can work with our partners, right,
Yeah.
as a team and try to do this. But you're right. The homeowner writes the check to
At
buy
the end of the day.
equipment. And do we know the features, the benefits, some of the payback, how it can benefit comfort and efficiency in that fine mix of those two things?
Right.
Where they will spend a little extra money.
Yeah.
You know, and to do that and to get that rebate and education, if they know it's an easy decision, but if they don't know, they're going to go back to the old single stage compressor on off.
Yeah.
And we know if it's off for a while and they turn it off,
We know
it
what's
takes
happening.
a lot of power to catch up.
Yes, it
So
absolutely
we don't want
does.
to do that.
So do we see from the Department of Energy side, do we see a lot of initiatives to help educate consumers and provide incentives for consumers to look at these new products to at least get that momentum up and running?
Yeah, so I mean, if we're talking incentives, there's a lot of them. The Inflation Reduction Act, obviously, so I'm sure everyone's
very
aware
important.
of, passed, what is that, almost 2 years ago now?
Been around.
And so there's a variety of incentives. There's the 25C tax credit, which folks can claim on their taxes. It gives you up to $2,000 off of a heat pump, I believe. The rebates, which are, I think, the thing people are even more excited about, are coming soon. Timeline still in progress. Each state has to go through a pretty long process to get their whole
Yeah, qualified and
exactly
established.
get qualified.
Yeah.
And make all the rules and then get approved by DOE. And some of the states are making their way. So hopefully, this year we'll start to see some of those programs get implemented, depending on where you live.
Sure.
But those can give you, anywhere from $4,000 to $8,000 off your heat pump, which at that point is
Now we're talking some money to invest into that difference.
You're getting those cost competitive with other options, and if it's also going to quarter your energy use, and at that
Long
point it's a
term, that's a
no-brainer.
big investment. Yeah, for sure. What about from like the utilities? Do we see a whole lot of that from Christopher?
Utilities are going to be really interested in demand response
Yeah.
or grid flexibility. They're going to be very interested in energy savings, but they always have to show that this is cost effective.
Right.
So
right.
that
makes
puts a
sense.
really unique barrier on the incremental cost compared to the amount of savings that occurs. And that's a slippery slope for a utility to deal with. So I'm not
Indeed.
quite sure how that's unfolding. I mean, in the Northwest, we're probably going to be pivoting towards a approach where we just don't want to see electric resistance heat used.
Yeah.
And that puts a lot of burden on the customer's contractor.
Options, yeah.
Like, make sure I've sized it right. Consumer education is one of these things that's hard to associate with. I was the one that got credit for educating the consumer, therefore I get to claim credit for the value that brought. And so this is a weak spot, honestly.
Okay, I can see that. Yeah, for sure. Okay. I like that, though. I mean, it makes us think, though. It makes us think outside of the box a little bit. And it gets us to form partnerships, for people to look at things slightly different than they haven't before. So let's talk about some of these partnerships. I mean, here we have manufacturers, we have trade associations and analytics, and we have Department of Energy. So we have a variety of aspects from the industry that are coming together to find solutions, really, to look at all of our options. So let's think about some ways that we can partner going forward, things that we can do together. Is there opportunities that we see to help bridge some of these gaps?
Yeah, I mean, that's kind of my job, is to find out what is the barrier to keep. And like the clearest barrier is price,
Yeah.
consumer price. But I don't have any lever I can pull other than the incentives, and that's really hard when I'm really faced with it's just in little incremental savings.
Sure,
So
absolutely.
that pivoted my thinking and those around and that works with me to like, okay, what are the incremental benefits that I can find that don't cost much? And this low load efficiency, this part load efficiency is one for certain applications. Dynamite, connected commissioning that we were talking about.
Absolutely.
Dynamite. There are a bunch of little things that kind of stack up on each other and increase value proposition. So my job is to find them, prove them, build partnerships with industry and DOE and the like, so that information can flow through to educators and the like.
Absolutely. Yeah.
But I don't have the resources to do a big
No.
campaign or anything like that. I am relying on others to actually get the message out.
Yeah, that's kind of why we're here. That's really why I struck that question, because it makes us all step back for a minute and go, what are my resources? What are the ways that I can connect? And that's what we're actually doing right here. We're joining forces to talk to a community about what we can do to make changes. You know, we build these partnerships, and because we all have questions. Manufacturers have questions on, you know, how are we going to promote this to my contractors? And there's going to be price increases, and there's going to be difference in the design of it. Who's going to be on my side to help educate me on what I can pass on to my contractors? What are the tools that they need? What are the rebates? What are the incentives that they have? Does it change from state to state? Because sometimes we're even seeing things like that. Some states promote more than others. So it's about these partnerships. So we encourage everyone to start joining us. I mean, that's why we're here at AHR. We encourage everyone to come visit us at the National HVACR Education Conference, where we come here and take a look at these pieces of equipment. We bring our manufacturers in to do technical training. We bring our trades associations in to go, okay, here's some of your resources. We bring departments of the United States to come in and go, well, here's what we see, here's the things that we're guiding, and here's things that we are utilizing to help get you resources. So let's talk about these resources before we start wrapping things up. Where would we go to at MIDEA to learn about all the things that we have in education and opportunities at MIDEA?
I would go to MIDEAevox.com. That's EVOX.com. It's got our products on there, a lot of exciting things, and then an email contact if you've got additional questions. So,
Sure.
I mean, at MIDEA, what we believe in, it's practical, innovative solutions, right? So it's not something crazy that someone can afford, but we try to find that sweet spot of what folks from every budget can afford, put in their house, and get the efficiency and the comfort that they're looking for.
Okay, sounds good. Christopher?
Yeah, that's a good one because I'm not actually doing that. But the people I would probably turn to is the Consortium for Energy Efficiency.
Yes,
CEE.
absolutely.
They're the ones that are setting the specifications for what is a tax credit eligible. So CEE. US EPA's got a great set of resources out there. And of course, your local utility is going to have their own flavor and twist on all this.
Yes.
And it's I think what likely will happen for a contractor is there will be a tax credit threshold, and then there'll be a little bit different nuance for that local utility's needs. Maybe they want demand response or grid flexibility more. Maybe they're really after low load efficiency.
Sure.
You'll find out for your local utility really quickly what is top on their mind. So those three.
Yeah, that's quite a bit. Alexander?
Yeah, I mean, we just have so many resources.
I know.
It's hard to track
That's
them
why
down.
I left you for last. We have a lot.
If you're interested in building science education,
Yes.
we have our Building Science Education Solutions Center, which has a variety of training resources that you can use to help educate contractors on a variety of different topics. If you're more of a builder and interested in looking at hardcore technical HVAC and envelopes things, we have the Building America Solutions Center. If you want to learn about our projects, you can head to the Building Technologies Office websites. EPA, like Christopher mentioned, has a lot of great information. They're launching a new consumer-focused campaign, which maybe helps actually target the consumer. It's called Energy Savers. ESHU. We have too many acronyms in government. I can't actually rename
Howard
it.
Weiss is out here. We can talk about acronyms all day long. Our industry loves acronyms.
Yeah, but really, I mean, we have so many, we can't direct you to all the websites, so we're trying to get all of our websites optimized for search engines, so all you're doing is just typing in what you want to Google, and the resource that we've spent money, your taxpayer dollars getting to you shows up so that you can find it and use it.
Okay. All right. Well, I thank you all for joining us at the 2024 AHR Expo, and we look forward to continuing these conversations with you. You can find us at escogroup.org, and we hope that you join us every week on our live Did You Know, the ESCO HVAC show.